Hello, my name is Jungwon. This is the code demonstration for ConnectR project for CS4242 Artificial Intelligence at Kansas State University 2016 fall semester. And objective of this project is to implement an AI agent utilizing MinMax algorithm to play Connect4 against human. And let me just walk you through just the basic of what I have done on my code. So first I have a board.java class which have a nested list of string builder. The reason why I'm using string builder instead of regular string is string builder is mutable, whereas regular Java string is immutable, which makes it a little harder to implement. And it has a number of column, number of row, number of connect to in order to win the game, and turn is the whose turn it is for the current board. And the board constructor takes number of column, number of row, number of connect, and who gets to go first, turn. And turn is actually an enum, consists of O and X. The O is representing the red disk and X is representing the black disk, and obviously the clone is to create an exact same object of the board. And I have a place disk method which takes number of column and then place the disk. If it successfully places the disk, then it returns true. If not, then it returns false. And is one method, this is where terminal states is defined. It first checks horizontally and then it checks vertically, then diagonally to see if there's any connect that satisfies the required number of connect to win the game. And is tie method check if the board is tie or not. If the board is full with the fill with the X or O, but no one's winning, then the game is tie. Then the print board. So the print board I'm actually printing out on the console as well as a display on the window using Java Swing. And this is just a basic picture of the black disk and when it's blank, when it's red, and nothing special about it. And the most connect method returns it takes the turn, so it takes either O or X and then find the most amount of connect on the board, and it returns integer of it. Okay, that's pretty much it for board. Let's look at the node. So node class is where it's the tree is constructed. It takes the board object and number of maximum depth, and then it generate all the possible states from that board until the specified depth. And this print tree is mainly used for testing purpose and generate possible states. So it basically try out every single column if that is reachable. If that's reachable, then it asks to the child node. And the utility, let's go to utility.java, and utility is where I have the heuristic value is defined this. So it min-max decision, it takes the board and amount of depth that it search through the board, and then the max player, you have to pass who's the max player of the board. And so this min-max decision method will return the integer, which representing the column, now which column to place the board, which column would be most effective to place for max player, of course. And the min-max decision we'll call evaluate node. Evaluate node. Then evaluate node will iterate through the tree, and then when it's at the leaf node, it'll call the evaluate node. Evaluate board actually. I'm sorry. Evaluate board. And evaluate board will take in the board and a max player. So if the board is 1 by max player, then it returns 1. If it's 1 by a min player, then it returns -1. And if it's tied, and it returns 0. If the board is neither tied or 1, then it will call the most connect method that I just went over earlier, divided by 10 value. So if X is the max player, and then there's 3 connect, then it will return 0.3. So that it'll always try to reach to the state where it has the most connect. Okay, and there's nothing special about main. It's just taking the user input, and alright, let's give it a shot. So first we'll ask the user to input dimension of the board. N is number of columns, so I'll put 7. M, let's do 6. Require connect, let's just do standard 4. And MinMax-Tree depth. So for my 16 gigabyte memory environment, 7 is max I can go, but I'll go 6 just to be safe. So it prints out this empty board, and then it will ask you to which game mode that you want to play. Let's do human versus AI, and I'll let the AI go first. So the way I define this min-max algorithm is that if the child node returns multiple max node, it will pick the last node on the list. So in this case, the reachable state is obviously 0, 1, 2, 3, 4, 5, 6, and then all of this node will return the same state value, so it picked the last column on the board. So let's try 0. It's thinking. Okay, 6 again. Let me do 1. 2. Oops. I didn't mean to let it win. Let's try it again. 2, 6, 4. Let's just do 5. That way it's faster. So since now I have a 3 connect, it places on 3 columns to block me from winning the game. So let's do 0, 0, and block me again. 1, block this guy from winning. I'll place 3. Yeah. So I know it's if the red plays in the column 1, it's gonna win, but I'm supposed to block it from winning. But let's see if this AI can't place it on the 1 to win the game. Nope, actually it did not place on the 1 column. Okay, where it was supposed to. That was a fail. I don't know why it's supposed to place on the 1. Oh, it won this time diagonally. Alright, so that was pretty much it for my ConnectR AI project. Thank you for listening.